Welcome to the Communication Software Lab. Today we are doing experiment to simulate generation of single sideband waveform for a single sinusoidal modulating frequency. The single sideband can be produced using a phase shift method. We have two balance modulators. To one balance modulator, cos omega mt and cos omega ct. They go together into that balance modulator. To other balance modulator, both the message and the carrier are phase shifted by 90 degree and they reach the balance modulator. If we add the output of these two balance modulator, we get LSB, the lower sideband. And if we subtract them, then we get an upper sideband. Here we use the Hilbert transform function to bring a phase change of 90 degree. The equations of the upper sideband and the lower sideband has been given here. MT is my message signal. Cos omega CT is straight away taken as the carrier with peak amplitude taken as one of the carrier. So MH is the Hilbert transform of the message signal. And when you open up the message signal MT, we get cos 2 pi FMT and cos 2 pi FCT is for carrier. If we subtract them, we get upper sideband. If we add them, we get the lower sidebands. This is the energy diagram, frequency diagram. And the upper one shows the message signal. And the second one is my amplitude modulated signal, which has the carrier as well as the two sidebands, upper and the lower. If the carrier is removed and one of the sideband is removed, the only one bands are left. Either it can be upper sideband left over there or the other is LSB. So this is shown in the third and the fourth graph. Since they are mirror images of each other, we can use either of them for message for transmission. Let's go to the octave and use the codes to produce the single sideband. My time is taken from range from 0 to 1 second with interval of 0.001. So the graph is plotted from 0 to 1 second. The peak amplitudes of the modulating signal are taken as 5. If this is 5, then I'll take the carrier to be peak amplitude of the carrier to be 10, so that the modulation index is less than 1. So it can be taken accordingly. If I take FM to be 10, then I shall take FC as 100, 10 times. M is my message signal. The instantaneous value of M is given as AM cos 2 pi FM the instantaneous value of the carrier wave is given as AC. Cos 2 pi FC. The Hilbert transform of the message signal is given as MH It's an as imaginary part of the Hilbert function M. The lower sideband is given as the message into cos 2 pi f c t. It's plus for the lower sideband mh sine 2 pi fm fct. So the upper sideband is the product of message and the cos 2 pi fct and the Hilbert transform and the phase change of the carrier. So this is the lower sideband. Now let's plot them. So I need the command subplot. So let's use, we'll have 5 figures. So subplot this, plot. The graph has to be between the time, and let's have the message first. Title, modulating signal. We can have grid on, and the X label I just give to one of the graphs. Let it to the first one, X label. I want it between time, Y label, amplitude, and let's have second graph as its Hilbert. So this is the second 5, 1, 2 plot. Graph is between time and Hilbert function mh, and let's have a title, Hilbert transform. Signal, let's have after this the carrier. So subplot 513 and plot t comma my this was carrier was BC. Carrier was BC. Okay, plot t comma BC. title, carrier signal. Subplot 514 plot t comma plot t comma. This is next is my carrier and the lower side band. Let me write this as but I have used it small letters only, so it's plot. Title, last one is the upper side band. Let's draw that also. 515 subplot 515 plot. I have I given equation for the upper side band? I don't think I've given. So I should write upper side band signal is equal to, I have message into cos of 2 pi fct minus mh sine 2 pi fct. See, let me just check. M into cos 2 pi fct minus mh sine 2 pi fct. This is my upper side band. Upper side band is equal to m into upper side band is equal to m into cos 2 pi fct, and there should be two brackets that was missing, minus mh into sine 2 pi fct. No, it's okay. So subplot 515 plot P is not working the key. Plot T comma upper side. So let's get the title. Upper side band signal. and all of them should have titles, all of them should have X label and Y label. So write accordingly. And we are done with the double sideband suppressed carrier. The top one is the modulating frequency, and this is the Hilbert transform of that. We can see there's a 90-degree phase shift in it. Right? Because if this is having a peak amplitude, there it is having 0 value here. So there's a 90-degree phase shift. This is my carrier, the third signal, and the lower sideband we will see will have a lower range of frequencies, and upper sideband will have a compressed band. So this is the upper. We are done with this experiment, and repeat this experiment for different sets of modulating frequency. Change the modulating frequency and try out how the upper sideband, lower sideband varies. So we are done with experiment. Thank you.